In this episode, we are going to cover the distance-distance intersection program. This program is used to determine the coordinates of an intersection based on two distances. We'll start by turning it on and right shift program, and make sure at the top right here, right shift, label, and we will label this program D. Left shift, flags, 1.0, EQN, RCL, D, RCL, I, RCL, S, RCL, T, and then we will use this minus as a dash, RCL, D, RCL, I, RCL, S, RCL, T, right shift, space, RCL, I, RCL, N, RCL, T. And this stands for distance-distance intersection. Right shift, PSE, EQN, RCL, I, RCL, N, RCL, T, right shift, space, RCL, O, RCL, N, right shift, space, RCL, L, RCL, E, RCL, F, RCL, T, right shift, space, RCL, S, RCL, I, RCL, D, RCL, E. Right shift, PSE, EQN, 1, RCL, S, RCL, T, right shift, space, RCL, N, RCL, O, RCL, R, RCL, T, RCL, H, RCL, I, RCL, N, RCL, G. Right shift, PSE, left shift, input, N, EQN, 1, RCL, S, RCL, T, right shift, space, RCL, E, RCL, A, RCL, S, RCL, T, RCL, I, RCL, N, RCL, G. Right shift, PSE, left shift, input, E. EQN, RCL, D, RCL, I, RCL, S, RCL, T, RCL, A, RCL, N, RCL, C, RCL, E. Right shift, space, RCL, L, RCL, E, RCL, F, RCL, T. Right shift, PSE, left shift, input, D. EQN, 2, RCL, N, RCL, D. Right shift, space, RCL, N, RCL, O, RCL, R, RCL, T, RCL, H, RCL, I, RCL, N, RCL, G. Right shift, PSE, left shift, input, Y. EQN, 2, RCL, N, RCL, D. Right shift, space, RCL, E, RCL, A, RCL, S, RCL, T, RCL, I, RCL, N, RCL, G. Right shift, PSE, left shift, input, X. EQN, RCL, D, RCL, I, RCL, S, RCL, T, RCL, A, RCL, N, RCL, C, RCL, E. Right shift, space, RCL, R, RCL, I, RCL, G, RCL, H, RCL, T. Right shift, PSE, left shift, flags, 2.0, left shift, input, J, RCL, E, RCL, X, minus, RCL, N RCL Y minus XEQ Y 0 0 1. Right shift STO G XY 1 8 0 plus right shift HMS right shift STO Q RCL D right shift X squared RCL G right shift X squared plus RCL J right shift X squared minus RCL D RCL G times 2 times divided by right shift arc cosine right shift HMS right shift STO R RCL J right shift X squared RCL G right shift X squared plus RCL D right shift X squared minus RCL J RCL G times 2 times divided by right shift arc cosine right shift HMS right shift STO S RCL J right shift X squared RCL D right shift X squared plus RCL G right shift X squared minus RCL J RCL D times 2 times divided by right shift arc cosine right shift HMS right shift STO T RCL, Q, left shift, HMS, RCL, R, left shift, HMS, minus, right shift, HMS, right shift, STO, A, left shift, HMS, XEQ, Y, 0, 1, 1, left shift, flags, 1, point, 0, EQN, RCL, I, RCL, N, RCL, T, right shift, space, RCL, N, RCL, O, RCL, R, RCL, T, RCL, H, RCL, I, RCL, N, RCL, G, right shift, PSE, left shift, view, N, EQN, RCL, I, RCL, N, RCL, T, right shift, space, RCL, E, RCL, A, RCL, S, RCL, T, RCL, I, RCL, N, RCL, G. Right shift, PSE, left shift, flags, 2, point, 0, left shift, view, E, left shift, RTN. And that is the end of the program, so now we are going to look at an example. Here is our example, and the way that this program works is, imagine that you are standing on point number 1, looking towards point number 2. This program is going to calculate the intersection to the left of the point that you are standing on. So it's going to calculate the northing and easting of point number 3. Let's say that we're out in the field doing RTK surveying. So we have a base station set up and we're hiking around looking for monuments with a rover. And let's say that this is a section corner and we get here and there's a bunch of trees, so we can't get a good fix with our receiver. What we can do is we can get a tape measure, measure it from the monument out to an open area where you can get a fix at, get the northing and eastings, and we have the distance that we measured with the tape measure. And on the west end, do the same thing, and you get the northing and easting for a point, and we have the distance from the tape measure. And with that data, we are able to calculate the coordinates for point 3 using the distance intersection program. We are going to use this example to test our program now. Okay, now we are going to test out our program using our example. right shift, program, XEQ, D, enter. And now we will put in the northing for our first point, which is 5, 3, 1, 8.970 RS. And the easting is 11571.350 RS. And the distance is 170.00 RS. And this is the northing for the point we are looking at, which in our case is 0.2, and that is 5, 2, 8, 2.390 RS. And the easting is 11284.110 RS. And the distance is 195.00 RS. And this is the northing for 0.3 in RS. And here is the easting for 0.3. If you got a different result than I did, then go back and double check. Make sure that you put in the northing and eastings and the distances in right. And if there's still a problem, then double check your program because there's something wrong with that. Now we'll turn the calculator off. We'll go RS, back, enter, left shift, off. See you guys in the next episode.